Okay, we're going to finish up our discussion on the method of finite differences by looking at how it works with a cubic sequence. So you've looked at linear sequences, give you an arithmetic sequence that had a first common difference. Second common difference give us a quadratic. Well, a third common difference is going to give us a cubic because it's a third degree polynomial function if we think back to x cubed. So let's come up with the general sequence by plugging in 1, 2, 3, 4, 5 into n in each of these cases. So let's kind of go from there. Plugging in 1, you get a, and then putting in 1 squared, so you get a plus b plus c plus d. Now plugging in 2 cubed is 8a. 2 squared, of course, is 4b. Plus 2c plus d. We got 3 for n now. 3 cubed is 27a plus 9b plus 3c plus d. Now we got 64a, 16b, 4c, and d. And now 125a plus 25b, 5c, and d. So let's start finding the differences by subtracting successive terms. So we've got, what is this, 7a. We're doing 8a minus a, of course. 4b minus b is 3b plus c. D minus d goes away. 27a. Here we've got 19a plus 5b plus c. We've got 37a, put that in here, and 7b plus c, and we've got 125 minus 64 is 61a plus 9b plus c. So that's the first set of differences. They are not common, so we'll have to keep digging to see what happens. So let's look at the second set of differences. 19a minus 7a gives us 12a. 37a minus 19a gives us 18a. And this one gives us 24a. And now to take care of the b's, we get 2b, 2b, and 2b, which is kind of a nice little thing there. And then finally, b's go away, we get 6a, and we get 6a. So this is our general form. We've got this big array of equations. So you can take any of these equations and line them up with a piece of the actual sequence once you make this array. So let's go ahead and do that for our example, and we'll refer back and forth between the two slides. So we've got this cubic sequence. Well, we don't really know it's cubic yet, but yeah, it's cubic. Spoiler alert. So let's write down the actual sequence here. So we've got the 5 terms laid out right here. So let's just jot them down. -6, 0, 24, 78, 174. Now, if you really wanted to, if you knew for a fact that this was a cubic sequence, you could use this, and this. 6, 0, 24, 78, and set it up with these 4 equations, because in order to solve for 4 variables, you would need 4 equations, and solve this system, and all is well and good with the world. Now, I'm not going to suggest you do it that way because, well, that would be a lot more work than doing it the other way. So let's go ahead and set up the array of numbers. Make sure it's cubic by finding that third common difference, and then we'll take it from there. So start finding your differences. This is 6, 24, of course, 54, and 96. No common difference yet. We'll do the next layer in green. So now we've got 18, 30, and 42. And we'll do the next layer, or the last layer, hopefully, in purple. So there's no first common difference. There is no second common difference. There is, however, a third common difference. So that is a good thing, which means it's a cubic. So let's start applying it. Now, look back. The 12 corresponds with the location of this 6a. So you can go ahead and start 12 equals 6a. A is, of course, equal to 2. So that's nice and easy. Now, when it comes to the green layer, you can choose any of these 3 green equations to line up with any of them. You could choose 24a plus 2b to solve for 42. I'm not going to do that because I'm a little more pragmatic than that. I'm going to go for the 18 and the 12a plus 2b because, well, the numbers are smaller. So why don't we go ahead and do that? So 12a plus 2b is equal to 18. So 12. Plug in your 2 from over here. And 18 minus 24 is negative 6. So 2b is equal to negative 6. Clean that up a little bit. So b is negative 3. So far, so good. Now let's go on to c. C's are in black. So again, I'm going to choose the most accessible number. These have the smallest A's, B's, and C's, so I'm going to go with that. So we've got 7a plus 3b plus c is equal to, in this case, 6. So plug in 7 times 2, 3 times negative 3 plus c is equal to 6. Simplify. 14 minus 9 is 5. So 5 plus c is equal to 6. So c is 1. And now we've got negative 6, a plus c plus d, a plus b plus c plus d. So let's go for it. A plus b, c plus d equals negative 6. Plugging in 2 plus negative 3 plus 1 plus d equals negative 6. Solving, so forth, so forth. Actually, 2 minus 3 plus 1 goes away, so d is actually equal to negative 6. So we've got our values of a, b, c, and d, which allows us to write the sequence. A sub n equals a n cubed plus bn squared plus cn plus d. And again, built-in checkpoints. Let's make sure that a sub n, is 24. So is a sub 3? So that's your built-in checkpoint. So 3 squared is 27, so that's 54. 9 minus 27 plus 3 minus 6. 54 minus 27 is 27, plus 3 is 30. 30 minus 6 is absolutely 24. So the third term is 24, which verifies, and we have now written the rule for a cubic sequence. Enjoy.